Last time, we discovered your ancestors ate bone marrow and honey and built the human brain. But at the end of that story, we left one question burning. Why did human skin change color as they spread across the globe? Around 10,000 years ago, a man died in what is now Britain. His skeleton sat in Gough's cave, buried, forgotten, until 1903. For a century, he was just another museum exhibit, a curiosity. Then scientists attempted something that would once have seemed impossible. They combined his skull with ancient DNA to reconstruct his likely appearance, and the result made headlines around the world because the analysis suggested highly pigmented skin and blue eyes. A dark-skinned, blue-eyed man in Britain 10,000 years ago. People called it shocking. Some called it a lie. Scientists called it probability, and it changed how we think about skin. Here is the question almost nobody can answer. If the first humans were dark-skinned, why do humans today have so many different skin colors? What color were the first humans? And why did that color change? The Old Human. Episode 13. What color were the first humans? Your skin is a document. Every shade is a record of where your ancestors lived, not a story of race, a story of sunlight. For hundreds of thousands of years, the sun wrote its history onto human skin. We're only just learning how to read it. How do we know what ancient people looked like? They're dust. We can't see them. Ancient DNA, paleogenetics. Scientists read the genes that control pigmentation, the instructions for skin, hair, and eye color, straight from bones thousands of years old. Cheddar Man wasn't simply imagined. His reconstruction was guided by ancient DNA, interpreted alongside his skeleton. Like all reconstructions, it comes with uncertainty. But here's the twist nobody expects. The first major change in human skin color might not have been dark becoming light. It might have been pale becoming dark. Long before Homo sapiens, our ancestors were covered in fur. Under that fur, their skin was probably pale, like a chimpanzee's. Then the fur disappeared, and bare skin met the African sun. So why did skin turn dark? For decades, scientists had one tidy answer. Skin cancer. The sun damages DNA. Melanin blocks the sun. Dark skin prevents cancer. Case closed. Except there was a problem. Most skin cancers develop after peak reproductive years. So many researchers questioned whether cancer alone could explain such strong natural selection. One of the strongest explanations involves vitamin B9, folate. Folate is crucial for reproduction and early development, and intense ultraviolet radiation can degrade it. So in the equatorial sun, darker pigmentation may have protected something more important than skin itself. It may have protected the next generation. Under intense equatorial UV, dark skin offered several overlapping advantages. It reduced ultraviolet damage. It may also have helped preserve folate, one pigment, multiple jobs. Evolution rarely has one answer. It usually settles for several good ones. In equatorial Africa, dark skin wasn't decoration, it was survival equipment. Then, between 70 and 100,000 years ago, humans walked out of Africa. Not one great march, just generation after generation drifting north. And as they walked, the sun got weaker. Less UV reaches the ground far from the equator. The shield that saved their ancestors was about to become a handicap. Skin makes vitamin D from sunlight. Vitamin D builds bones. At high latitudes, highly pigmented skin needs much more sun to make the same amount. Where diet couldn't compensate, that created strong pressure for lighter skin. Children needed vitamin D for healthy bones. Women needed it for safe childbirth. The story is a balancing act, not a death sentence. So the story should be simple. Dark in Africa, light in Europe. End of story. But it is not that simple. And here's where the science gets strange. Because for tens of thousands of years, many Europeans still carried the genetic signatures of darker pigmentation. Ancient DNA reveals a Europe that looks nothing like today. Several hunter-gatherers from Central and Southern Europe carried combinations associated with relatively dark skin. Meanwhile, some northern groups already carried light pigmentation variants. Ancient Europe was a mosaic, not a south to north color slide. And some of those dark-skinned Europeans had blue eyes. Everyone imagines evolution as a ladder. Dark, brown, white, nice, and neat. Reality, a patchwork. Different populations, different genes, changing at different speeds. Skin and eye color evolved separately. Evolution didn't march in a straight line, it scribbled. And suddenly Cheddar Man doesn't look unusual anymore. He looks exactly like one piece of a much bigger human story. About those blue eyes, you've heard the claim, every blue-eyed person descends from one single person. Many blue-eyed people do share a major genetic variant near a gene called OCA2, suggesting one common ancient origin. But eye color isn't controlled by one gene alone, and science can't name one first blue-eyed man or woman. Never trust a tidy story about your own face. That's a lesson in itself. So what finally changed Europe? Farming may have accelerated it. Grain-heavy diets supplied less vitamin D than diets rich in fish and wild animal foods. Meanwhile, new farming populations brought their own pigmentation genes into Europe, and natural selection kept working on them. Agriculture didn't flip a switch, it leaned on the dial. Europe's appearance also changed through migration. Hunter-gatherers mixed with incoming farmers. Later, populations carrying steppe ancestry arrived from the east. These movements reshaped the frequency of pigmentation variants. The modern European face wasn't created by one migration. It was assembled over thousands of years from thousands of lives. And Europe wasn't special. The same trick happened in Asia, independently. East Asians evolved lighter skin through entirely different genes than Europeans. Same result, different biology, convergent evolution. When nature keeps reinventing the same answer from scratch, you know the question mattered. Now the question every comment section asks, what about the Inuit? They live in the Arctic, where for much of the year there is very little UVB available to make vitamin D, and their skin is still dark. The answer, their traditional diet, fish and marine mammals, supplied vitamin D directly. That reduced dependence on skin synthesis. Food did the work the sun couldn't. And there's one more thing almost every video misses. Modern humans met Neanderthals, we met Denisovans, and we had kids with them. Some Neanderthal-derived variants influence traits involving skin and hair. Your body might be carrying a scrap of an extinct relative, but your skin color is shaped mostly by a much bigger network of your own genes. Think of skin color as a dial, not a label, a control your ancestors adjusted to match the world they lived in. Turned up near the equator, turned down near the poles. Every setting was correct, and for the place and time it was dialed. So here's the uncomfortable part. Human societies turned a flexible adaptation to sunlight into a rigid social hierarchy. Biology never created those categories. People did. Skin color does not divide humanity into neat biological races. It's a continuous trait, shaped by ancestry, UV exposure, migration, and time. Similar shades can evolve through completely different genes. Color is a map, not a rank. And now, things are complicated, not because evolution stopped, because we outran it. People move between ultraviolet environments faster than natural selection can follow. Clothing, indoor life, diet, and supplements all blur the old relationship between skin and sun. Some combinations of pigmentation, lifestyle, and latitude raise vitamin D risk. Others raise UV risk. Your skin is calibrated for somewhere. It just might not be where you live now. 3 things the old human teaches you about skin. 1. Dark pigmentation is not primitive. It was a crucial adaptation that evolved after our ancestors lost their fur. Lighter skin evolved later, in several populations, independently. 2. Skin color is not a measure of worth, it's a flexible response to environment, diet, and history. 3. Every human alive belongs to one young, closely related species whose superficial differences evolved remarkably fast. Cheddar Man wasn't an exception, he was a reminder. Human history is far stranger than the stories we tell ourselves. If you could stand beside Cheddar Man today, you probably wouldn't see a stranger. You would see family. After all, every person alive descends from the same small population that once lived in Africa. The differences we notice today are remarkably recent. Human skin did not evolve to divide us. It evolved to keep the same human body alive under different suns. Look at your hand. Every shade of it is correct. An answer to a question asked by the sun, and every single answer was right. Subscribe for more stories about the mismatch between your ancient body and your modern world. Next time on The Old Human, we've just seen how the sun rewrote human skin. But there's a story the history books barely mention. How did ancient women survive periods, pregnancy, and childbirth? In a world with no medicine, no painkillers, and no privacy, the fire is still burning. This is the old human.